This video is going to show how to use the ladder method. Sometimes this was called the birthday cake method, but I learned it as the ladder method. The ladder method can find the greatest common factor and the least common multiple at the same time with a minimum amount of work. But first I want to get a definition of what the greatest common factor is. So I'm going to pick two numbers here. So I have 4 and 6. And what a factor is, a factor times a factor gives a product. So a factor times a factor can give me 4. I want to list all the factors that can give me a 4. So I need factor pairs. So I have 1 times 4 is the first one. 1 times 4, factor times factor gives me this product. And another two factors that can give me 4 are 2 times 2. Well, since the numbers have repeated, we're done on this one. And then for the 6 over here, it's 1 times 6 for the first factor pair. Then I move to 2 because this is a 1. Then I go to 2 times 3. And then I can go to 3. But 3 times 2, this one is the same. These two factors are the same as these two. Since they're a duplicate, I'm just going to cross them off. So then I look at this, and greatest common factor means which is the biggest factor that they share in common. Well, looking at these, the biggest number that they share in common is a 2. So the GCF is a 2. Now we'll look at the least common multiple. To find the least common multiple, I first want to explain what the multiples are. So our two numbers were 4 and 6. So I'm going to list the multiples, which means multiply. I'm going to do 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5. I'm going to stop and I'm going to start on the other one. So then I have 6 times 1, 6 times 2, 6 times 3. I've already found the smallest multiple that they share in common is a 12. So the LCM is a 12. If these are really big numbers, I don't want to have to list the multiples of there. So that's what the ladder method is for. It gives a real fast answer. And I'm going to do 3 problems using the ladder method to show the GCF and LCM at the same time. So using our example of 4 and 6, now we knew that the GCF was 2, and we knew that the LCM from listing the actual multiples was a 12. Now we'll use the ladder method for this to see where we go. So for the ladder method, it's just ladder. These are like ladder steps. So what I'm going to do is I'm going to find the smallest prime number that goes into both. And the reason I use prime numbers is because every single number can be reduced down to a product of prime numbers. This makes it a very efficient, very easy way of breaking down any number. So these are all the prime numbers between 0 and 20. And I start with number 2. And then in order to find out if a number's evenly divisible by 2, there are divisibility rules. These two numbers are both even, so they are divisible by 2. So I put a 2 here, and then I'm doing division. So what I want to do is I want to now do the division. 4 divided by 2 is 2, and 6 divided by 2 is 3. We're actually done with this one. The side number over here, that is the GCF, and we can see the GCF is 2. To get the LCM, well, the LCM is going to be all of the outside numbers, 2 times 2 times 3, all multiplied together. So I do these two first. 2 times 2 is 4, and I bring down the times 3 and cross it off. And then 4 times 3 is 12. So there's the LCM. And we'll just try a couple of other problems. And it gave me both the GCF is just this number, any side numbers. If there's more than one, we'll look at the next problem. If there's more than one, we would multiply these side numbers. And then the LCM are all the outside numbers. So let's try another example. So we'll pick two new numbers. We're going to do 8 and 20. Now, I certainly wouldn't want to list the multiples for all of these and find all the factors. As the numbers get big, then we would be doing a lot of work. So once again, I'm going to list the prime numbers: 2, 3, 5, 7, 11, 13, 17, and 19. Did I forget one? No. So these are both even numbers. So once again, these are both divisible by 2. So I have 8 divided by 2 is 4. And then I have 20 divided by 2 is 10. These are still divisible by 2, so I'm going to make another ladder step. And it starts to look like a ladder here. So then, since they're both divisible by 2, I put the 2 here, and then I have 4 divided by 2, and I have 10 divided by 2. These are all prime numbers on the outside, so I'm done. So the GCF are going to be the two side numbers here. So 2 times 2, so the GCF is 2. Excuse me, 2 times 2 is 4. And the LCM, well, the LCM is going to be all of those numbers multiplied by each other. So I have 2 times 2 times 2 times 5. So 2 times 2 times 2 times 5. So I do these two first, I get a 4. And then I'll do these two, I get 10. And 4 times 10 is 40. So the LCM is 40. I'll do one more example. So the two new numbers are going to be 18 and 24. I put them in the ladder step. My prime numbers are 2, 3, 5, 7, 11, 13, 17, and 19. Now, if you're doing these for school, you can just write this one time in your notebook and keep referring back to it. So both of these are even numbers, so they're divisible by 2. 18 divided by 2 is 9. 24 divided by 2 is 12. I'm done there. Now, 9 is not an even number, so we're done with 2. We can't use that one again, but they are both divisible by 3. I know that 9 is divisible by 3, and to find out if a multi-digit number is 3, we add up the numbers. So 1 plus 2 is 3, so 12 is divided by 3. So I'm just putting that in there for the divisibility rule. So 9 divided by 3 is 3, and 12 divided by 3 is 4. These are prime numbers, but since this is a prime number, they're not going to share any factors in common. So my GCF, if I look over here, my GCF is 2 times 3, so the GCF is 6. And then the LCM is going to be 2 times 3 times 3 times 4. I'm just taking all of these numbers, 2 times 3 times 3 times 4. So I'm going to do 2 times 3 is 6. I'm going to do 3 times 4 is 12. And then I multiply these two together and I get 72. So my LCM is 72. You can see that since the GCF and LCM, not so much the GCF, but the LCM can start becoming a really big number, and I might not want to do that. So let's look at I'm just going to touch upon adding fractions together to show how the LCM would be something that we can find fast. So let's say that I had to add 1/10 plus 7/12. Well, I need to find the least common multiple so I can find the least common denominator. So a fast way to do that is to come over here and I put in 10 and 12 into the ladder. And they're both even numbers, so I can divide by 2. 10 divided by 2 is 5. 12 divided by 2 is 6. And I'm done because my GCF is 2 and my LCM are all these numbers multiplied. So 2 times 5 times 6. So the LCM is going to be 10 times 6 or 60. So the LCD for my fractions is going to be 60 and 60. Well, going from 10 to 60 is times 6, so my new numerator is 6. And to go from 12 to 60 is times 5, so my new numerator is 35. And I add these two together and I get 41 over 60. 41 is a prime number, so I'm actually done. And that's an example of what we would use this for. Hope that helps.
That was easy.